All right, this is a Section 5.2 extension. I've not got a lot of notes for you to take on this one, so I didn't want to waste a lot of paper other than just giving you some examples. But the biggest thing that we have here is I'm going to give you a graph, and your job is to tell whether that this is a proportional relationship. So last time I gave you basically a ratio or a fraction, and I set it equal to another ratio or slash fraction. And if this ratio and this ratio were the same, they were proportional. And that was how we can do it. And we can kind of prove this on calculator. 1/2 is 0.5, 2/4 is 0.5, and we know that these two are proportionate to one another. However, when it comes to stuff like this in graph, we have another little rule that we can tell if things are proportional, and it's this. If the graph created is a straight line through the origin, it is proportional. All right, so this is just one of those rules. So we need to make and see if this will create a straight line, and not only that, we need to see if it goes through the origin point. So let's just go ahead and do a couple of these real fast, and let's I'll do 1 and 3 with you because those just to start you off. So first off, let's go ahead and plot a couple of things. First, this is going to be my origin point right here. This is where my origin is. This is going to be my y-axis, and this is going to be my x-axis. And according to this, I need to plot these x and y values. So how do we go about doing that? Well, we need to realize that these represent an ordered pair. This is my x value, this is my y value. So together they would make an ordered pair of 2 and 5. This would make an ordered pair of 3 and 7. This would make the ordered pair of 4 and 9. And lastly, this would be the ordered pair of 5 and 11. So those are my ordered pairs. Now that I know that, I can plot them on a graph. But before I can even do that, I need to get my graph set up. So if we look at our x values, we're counting by ones because it goes 2, 3, 4, 5. So I can kind of do the same thing down here. I'm going to count by ones. 1, 2, 3, 4, 5. That's good enough. All right, let's look at this one. It's going up by 2s, and it goes all the way to 11. So can I count by ones all the way up? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I can't. So that means that probably for my y-axis, I need to count by a scale of 2. So this line would here be with 2, 4, 6, 8, 10, 12, and I think I can stop because I don't go any higher than 11. Now that I've done that, I can actually start plotting these ordered pairs. 2 and 5, so I'm going to start my origin. I'm going to run to 2, and I'm going to jump to 5. 3 and 7, I'm going to start at my origin, run to 3, jump to 7. Then the next one is 4 and 9, so run to 4, jump to 9. And the last one is 5 and 11, so I run from origin to 5, and I jump up to 11. Now that I've done that, let's just go ahead and create a line here. So, when we look at this, and I've got my line here, does it go through the origin? Well, it kind of looks like it, but it does not go through the origin point. It really goes through right here, which is about the 1. So this right here is not a proportion because it does not go through the origin. Well, let's try number 2 then. We're going to do the same thing. Let's go ahead and label our ordered pairs in this. This would be 1 and 3, 2 and 6, 3 and 9, 4 and 12. So our job is to see, will this indeed be a proportion? So let's set it up again. I know that this is going to be my y-axis, this is my x, and right here will be my origin point right there. So let's label, since this is counting by ones again, but we don't have to have as many. Let's see if we can skip some lines. So I'm going to skip a line, put 1, skip a line, put 2, skip a line, put 3, skip a line, put 4. So good, yeah, I can count like that. That way I can make my graph a little bit bigger. And it looks like I'm counting by 3s on my y, so let's do the same thing. This time I'm going to skip a line. So I'm going to skip a line, put 3, skip a line, put 6, skip a line, put 9, skip a line, put 12. Cool. So I've got a bigger graph this time I can work with. So let's plot our ordered points. 1 and 3, that's cool. 2 and 6, easy. 3 and 9, and 4 and 12. Now I'm going to do the same thing. I'm going to draw a line through all of them and see what happens. Look at what happens in this one. When I draw my line, it actually goes through my origin point. So this is, yes, it is a proportion. So what I want you to do is I want you to try 2 and 4 on your own, but I am going to give you a little bit of a hint here on number 3, because look at what happens here. This is actually the more difficult one because your y values are counting by 2.4s. So make sure that you set your scale up on your y to accommodate that, all right? And once you pause the video and try these on your own. What you should have got was something like this. Notice how on my y-axis, I actually counted by 1.2. You could have counted by 2.4 if you want. If some of you counted by, say, counted by 1s or counted by 2s, it made your life really difficult for the simple fact that you got a decimal there. And it's kind of hard to put a decimal, a place value right where the decimal is if you're counting by 2s. So this is why I kind of gave it to you a little bit, is I wanted you to be able to realize that you can count by any number you want. So count by the easiest thing there is. In this case, 1.2 was the easiest thing for me. Now that I've got it graphed, as you can see, I have a straight line. It goes through the origin. So yes, this is a proportion. And then we look at the other one. This one was much easier to graph once we do it. You should have gotten that it actually crossed at the crossed at 1, according to my graph anyway. So in this particular case, no, it is not a proportion. So this next one is something that confuses a lot of students, both young and old. And it's this concept that says interpret each plotted point in the graph of the proportional relationship. And the word there is interpret. So interpret simply is asking you to tell what something means, all right? So most of the time when we're looking at math, we get some numbers, but that's all we usually like to give people is like numbers. But what do those numbers mean? They can mean a lot of different things, and so that's where interpretation is coming from. So here we have a graph, and we need to interpret each one of these ordered pairs. So I have an ordered pair of 0, 0, and it's asking me, what does that mean? Well, there's 3 things that we need to look at. One, we need to look at what's called the title. So this is the title of this graph. It's about a car. So that's easy. So this car. And then we need to look at what our X and Y values actually represent. So this X, I have a bunch of numbers, 1, 2, 3, 4, actually represents hours. So this is not just the number 1, it's 1 hour, 2 hour, 3 hour, and so forth. This Y-axis is actually the distance in miles. So it's not just 20, it's 20 miles, 40 miles, 60 miles, and so on. Now that I know that, I can look at this ordered pair and actually make a little story here if I want to and explain what this ordered pair means. I drove 0 hours for a total of 0 miles. Basically, I traveled nowhere. I didn't leave. I stayed right where I was. So I drove 0 hours for a total of 0 miles. So what does this next order pair mean, 1 and 60? Well, it means I drove 1 hour for a total of 60 miles. And then lastly, we have 2 and 120. So I drove 2 hours for a total of 120 miles. Now, 6 is pretty much the same thing. We got to look at the graph. We have a bunch of points here, and we have the point 0, 0. We have the points 4 and 40. We have the point 770, but the question is, what do they mean? So take a moment. I want you to do the same thing for 6, 7, and 8, and I want you to interpret what these mean. All right, so for number 6 here, if we go to interpret this, it's for 0, 0, it means 0 pounds of shrimp costs $0. 4 and 40, or 4 pounds of shrimp costs $40. And lastly, the 7 pounds of shrimp costs $70. Now, this is just an interpretation of my own. Now, you may have wrote yours slightly different, and if you did, that's okay, as long as you get the concept of 0 pounds is $0. You could have done slightly different, as long as you got that concept. And it's the same thing with number 7 and number 8. I'm actually going to pause the video here and let you kind of look at it on your own. So after looking at it, yours should be very similar to these same things. And again, I'm not going to read these for the sake of time, not to keep this video but so long. And that's pretty much it. So the highlights of this thing. In order to check to see if a table is proportional, basically just plot it and do a line. And if it crosses the origin, it's proportional. If it doesn't, it's not proportional. And make sure that you understand the concept of interpret, because these numbers, like I said before, have meaning. They mean something. And that's all I want to do in this video. If, as always, you need me, ask questions, and I'll see you in the next one. Bye-bye.